In the previous video, we wrote all formulas that we need to solve problems on work and work-energy theorem. And now let's solve problem 1. I will write the formulas that we will need right here. What is work done by force? It is definite integral from R1 to R2 f dot dr. It depends on path. And it is equal to integral from point x1, y1 to x2, y2, fx dx, plus integral from x1, y1 to x2, y2, fy dy. And we also wrote work-energy theorem that tells us that work done by the net force is equal, as always, to integral R1, R2, F net dot dr. And this is equal to the change in kinetic energy, mv2 squared over 2 minus mv1 squared over 2. So, problem 1. For problem 1, we will have a block with given mass m. M is 16 kilograms. And then there is a force acting on this block. The force has magnitude F naught, which is 30 newtons. And it is acting at angle 37 degrees. Theta is 37 with horizontal. There is friction between the block and the surface, and this friction impedes the motion. Then we know that the block moves to the right. It's given that the block moves to the right distance of 10 meters. So if it is 0, then this is d, and this d is 10 meters. We also are given that block starts from rest. Velocity at time moment 0 is 0. And velocity at time moment 0, t2, when the block is at point D, the magnitude of the velocity at t2 is given. It is 3 meters per second. So I will move F naught a little bit to have it less crowded. This is force F naught. Part A. We need to find work. What is work done by constant force F naught when the block moves 10 meters. What will we do? Well, the force is, here's the formula for work. The force is constant, so we can write work as just dot product of force dot displacement. And from this formula, I will get F naught times d times cosine theta. Or I look at this formula, which is general formula. This is just one particular case when force is constant. So I look here and I immediately understand that F sub x is F naught cosine theta. Integral dx will give me just x, x2 minus x1, which is d. Fy is F naught sine theta, but the limits here from y1 to y2, the limits are both 0, so displacement is 0 in y direction. Second part of the integral will give me 0. We have just this. So we found the work done by constant force F naught. And if I plug in the numbers, I will get 2 40 joules for work done by this force. For part B, they ask us, what is the coefficient of friction? What is the coefficient of friction between the block and the surface? I need to find mu. There is non-zero coefficient of friction between the block and the surface. So what is this? What is it? And to find coefficient of friction, I will use Work-Energy Theorem. We will apply Work-Energy Theorem to this situation. So let's look what we are given. We are given initial velocity. We know final velocity. So we know the right-hand side of this equation. If I can find work done by each force, I can solve for the coefficient of friction. So let's do that. We need to draw the free body diagram for this block, isolate it, and draw all forces applied to this block. There is force of gravity vertically down. There is normal force vertically up. There is force F naught, constant force acting on the object at angle angle theta that is given. And there is force of friction that opposes the motion, force of friction to the left. So here are all forces. We already found work done by F naught. Now let's find work done by gravity. Force of gravity is perpendicular to displacement. So cosine of 90 degrees is 0. Dot product is 0 and work done by gravity is 0. If you look at this formula, you will also see it immediately. You know F sub x, there is F sub y, but displacement is 0. Y1 and Y2 both are 0. There is no displacement in y. We are done with work done by gravity. By the way, let's introduce coordinate system that I forgot to introduce. Let's x be to the right and y be up. Why not? X and y. What is work done by normal force? Work done by normal force. Work done by normal force will be also 0 because, again, normal force is perpendicular to the displacement. Perpendicular to displacement. Next, what is work done by friction? Work done by friction. Work done by friction, I will probably write this integral. We go from 0 to d, from 0 to d, from x1 to x2. F sub x is minus mu n. The block is moving, the friction is kinetic friction, so magnitude of force of friction is mu n, and projection is negative because my x is to the right and force of friction is to the left, so it is minus mu n dx. Nothing depends on x, so I take mu n out of integral and plug in the limit. D minus 0 is 0. Or if I just use my dot product formula, I have magnitude of friction, mu n, magnitude of displacement d, times cosine of angle between them. Angle between displacement and friction is pi, and cosine pi is minus 1. Well, everything works. Now the question is, what is n? I don't know n. N is not given. I also don't know mu, but I'm looking for mu. So what is n? How to express n in terms of other forces that are given? I will use second law to do that in projection in y. Fy may. What do I have in y? I have normal force up, gravity down, it comes with minus. Then I have vertical projection of force F naught. from this triangle, I immediately see that the projection of node F node is positive, so it is plus F node sine theta. And the block is not moving in y direction, so this is 0. Okay, great. What is normal force then? Normal force is equal to mg minus F node sine theta. So we express normal force in terms of what is given. And work done by friction is equal to minus mu n, which is mg minus F node sine theta times d. Great. So now we know work done by force F node, work by normal force, work by gravity. We need to add all of them and put them equal to the change in kinetic energy. Let's do that. So work done by gravity. What I'm doing is work done by gravity plus work done by the normal force plus work done by work done by force F node plus work done by friction. And this is equal to mv2 squared over 2 minus mv1 squared over 2. We are given that the initial velocity is 0. We know v2. So what is the left-hand side? This is 0. This is 0. Work done by F node is F node d cosine theta. Work done by friction is minus mu mg minus F node sine theta d, and this is equal to mv2 squared over 2. Oh, look at this. We have one equation and one unknown variable, which is coefficient of friction. We can solve this equation and we can find the coefficient of friction. I will write it here. I will move here. So what is the coefficient of friction? I can move this guy to one side of equation with plus, then this guy will come here with minus, and what will be mu? Mu will be, I have fd cosine theta, F node d cosine theta, this guy, minus mv2 squared over 2, and divide by all this. Divide by mg minus F node sine theta. F node sine theta in parentheses times d. I know everything in this formula, so if I plug in the numbers, F node is given, d is given, theta, v2, m. If I plug in the numbers, then I will get 0.121 for the coefficient of friction. We found the coefficient of friction. We solved the problem.